Good morning. So again we'll start with the problems where relapse. So before starting, again I am going to write down the procedure because this is very much important in solving the problem. And you need to write this procedure step by step while solving the problem. That's why I am repeatedly stressing on this. The first one is the decide required manufacturing datum. Manufacturing datum. Second, decide required manufacturing dimensions. Decide required manufacturing dimensions. In the bracket you write, which also includes deciding Vomitech dimensions. Includes deciding Vomitech dimensions. Third, determine the tolerance for each of the new manufactured dimensions. I'm just writing it short over here. Four, set the limits for all but one of the required dimensions. Last one, that is the fifth, determine the limits for all final dimensions. These are the steps which we need to remember. Next, they take down the numerical. The slide box shown in the figure the slide box shown in the figure is to be manufactured in batches of to be manufactured in batches of 100 is to be manufactured in batches of 100. First bit, that is the A. Determine a method of manufacture intended to reduce machining time. Intended to reduce machining time. Machining time. And then reduce the block showing the appropriate manufacturing dimensions. Dimension. The diagram is as shown in the figure. It's over here. And there is a hole. Okay. This dimension they have mentioned. So that is 40.09 to 39.9. .980 this dimension. 24.980 to 24.947. And then this dimension they have mentioned, that is 15.03 to 14.97. 14.97, and they have mentioned this dimension also. I'll write it over here. 15.06 to 14.97. This is 15.06 to 14.97, and this dimension also they have mentioned, that is 25, and the overall length also they have mentioned, it is 80. The overall length also they have mentioned, it is 80. Now, the side block shown in the figure is to be manufactured in the batches of 100. The slide box is shown in the figure, and they have asked you to determine the method of manufacture intended to reduce machining time. That means they have asked the sequence of operations, and then they have asked to reduce the block showing appropriate manufacturing dimensions. That means they want the new manufacturing layout. So before starting with the procedure, what we need to do is that what we have followed in the previous problem, we need to write first, we need to show first the functional datum. We need to show first the functional datum. So I'll just redraw this diagram over here. Over here I draw without any dimensions. Without any dimensions I'll draw. So without any dimension, this is the diagram. So the functional datum, I told whenever, what is the functional datum? The functional datum is that datum which defines the functionality of the component in the assembled condition. So it can refer any face, axis or edge which defines the functionality of this component when it is assembled. So in any component you may notice if there is a hole, then the axis of the hole becomes the functional datum. So if you can notice over here in this component there is a hole over here, and hence the axis of this hole becomes the functional datum. The functional datum you need to mention as XX. Is that clear? And then we need to write for the first A the machining sequence. Now here, what are the machining operations required? First, milling all surfaces, or I can write milling all faces. Then drilling hole dimensions, they are not mentioned. Drilling hole. Drilling hole. Now we'll start with the procedure. And the first step, what it is there? It is decide the required manufacturing datum. You need to write that first. Decide the required manufacturing datum. So here in this particular part drawing, so what I can say is that the functional datum axis I have taken as the functional datum. So what dimensions determine the functional datum or attached to it? This dimensions have this dimension. That means this feature is attached to that. But this feature, although it has tolerance, but it is not attached to any dimensions. You can see. Hence, you can take either this face or this face as the manufacturing datum. So I'll prefer this face. As manufacturing datum. Okay. Then second, decide required manufacturing dimensions. Decide required manufacturing dimensions. In the bracket also they are asked, which also includes deciding geometric dimensions. deciding omitted dimensions. So I'll take the part drawing again for this. Now, which all dimensions I need to consider? As I had decided this as the functional datum, the dimensions with respect to the functional datum, that is this, that is 15.032, 14.97, 032, I'll just write it. I'm just redrawing this section a bit because it might be clearly visible for you people. So now, what is the dimensions they have mentioned? 15.032, 14.97, and one more dimensions is this. What is that? 15.062, 14.97. So these are the important dimensions. So within this tolerance, because this we are not considering because it is not attached to any functional datum, and it is free of any dimensions attached to it. Hence we are not considering these dimensions now, and also we are not considering these dimensions, and this y direction dimensions also we are not considering because we are considering only the x-axis dimensions as we have taken this as a functional datum. Now these are the two dimensions. We'll just name it as A and B. Okay, so what are the tolerance of A? That is 15.03 minus 14.97. That is 0.06, isn't it? And then for B, it is 15.06 minus 14.97. So just make it as 696, sorry, 14.96. Okay, 14.96. I'm sorry for that. That is 0.10. So which is having the maximum dimension? Sorry, maximum tolerance among A and B? It is this. It is this. Hence we are going to omit this dimension. So hence we are showing B, and in the bracket we are going to show the symbol of O. That means this dimension has been omitted. But if you are considering only these two lengths, and if you are omitting this, then these dimensions will be omitted, right? But there must be some other dimensions to define this length. Hence I am considering this length, that is Z. Is that clear? Is that clear? Just so for that, the dimensions was 15.06 to 14.97, and here also I taken the same dimensions, and here also I taken the 14.96 only. And this is the diagram with respect to the second. And third step, So third step only we have done. The tolerance also we have found out. The third, the tolerance for the new dimensions, that is this and this we need to find out, that is determine the tolerance for each of the new manufactured dimensions. Determine the tolerance for each of the new manufacturing dimensions. Now, which are the new manufacturing dimensions? If I omit this, the new manufacturing dimensions are A and Z, Z. And the omitted tolerance was 0.10. Hence, this has to be equally distributed among this. That is 0.05 and 0.05. 0.05 and 0.05. Now I just take A, limits of A. So the limits of A was already mentioned, it is 15.03 to 14.97. 15.03 to 14.97. That means it has a tolerance of 6 mm. It has a tolerance of 0.06, but it has to be 0.05. Hence, I'll keep the upper limit same, 15.03, and I'll change the lower limit 4.98, so that the tolerance will be equal to the set tolerance, that is 0.05. And for the Z also, it is 0.05. That is Z plus 0.05 and minus 0.05. So is that clear? So I'll just write for my reference, it is, what is the new dimensions I have taken? 15.03 to 10.98 for B. For B. It is for my reference I have written. Next, the fourth step, set the limits for all but one of the required dimensions. So I set the limits here itself, like for B we have set as same 15.03 to 14.98, and for Z what we have set, that was 0.05, hence I am showing it as plus or minus 0.05. Again it is shown in the figure. Next, determine the limits for all final dimensions. Limits for all final dimensions. Now I take this diagram as a reference, and I need to decide the limits for all final dimensions. That means for the Z I need to decide. For Z I need to decide. Hence, what am I going to do is that with respect to the omitted dimension, I will write the equation as, in this present diagram, B is equal to Z minus A. B is equal to Z minus A. Now, this is a condition. So, I need to write this condition with respect to maximum B and minimum B. So, first I am going to write for the maximum B. When B is maximum, what happens? What will be the condition of A and Z? When B is maximum, the A will be minimum and Z will be maximum. When B has to be maximum, then Z has to be maximum, and B has to be maximum. The Z has to be maximum and A has to be minimum. Z has to be maximum and A has to be sorry, A has to be minimum. Hence, substitute the value of B max, that is 15.03, the new B max. And Z max is what we need to find out. And A minimum is, B max is 15.06, sorry. 15.06, sorry. B max is 15.06, that is the omitted dimension. Z max we need to find A minimum, that this will become A minimum is 14.98. A minimum, what we have changed the new one to 14.98. So hence Z max is equal to 15.06 plus 14.98. .04, that is 30.04, and then we write the same for B minimum condition. When the B will be minimum, when this B will be minimum, when Z will be minimum and A will be maximum. When this B will be minimum, when Z is minimum and A is maximum. Z is minimum and A is maximum. B minimum is 14.96 and Z minimum is what we need to find. A minimum is, sorry, A maximum is 15.03. Hence, Z minimum is 29.99. 29.99. Hence, I'll going to write this answers also. That is, Z max is I'll just write for the values of Z as maximum is 30.04 and minimum is 29.99. So if you remember, we had decided the tolerance of Z as 0.05 only, and the answer has come. For that, upper limit is 30.04, 29, lower limit is 29.99. So hence the tolerance for this is also again 0.05 itself. So it has satisfied the condition. So I'm just going to rub this, and then I'm going to draw the new manufacturing layout, wherein I'm going to eliminate the omitted dimensions. Just I have eliminated. Okay, and then I'll show the dimensions of Z. I'm going to show the dimensions of Z, that is 30.04 to 29.9. And datum we had decided this. This also I'm going to show. And the remaining dimension, sorry, for this wavered line, and remaining dimensions I'll show as it is mentioned in the problem. That is, this one is 24.98, 24.947, and this dimensions also I'll show because it was mentioned, 40.09 to 39.91 to 40.09, and this length I'll show over here. As 80. and this is 25. So this is the new manufacturing layout. So this dimensions has been omitted. Instead of that, I have mentioned one more dimension with tolerances. So that is the new manufacturing layout. With that manufacturing layout and with that datum, it is very easy to manufacture this component rather than this layout, just by changing the datums. Is that today and tomorrow we'll finish this. The next one, for the component shown in the figure, for the component shown in the figure, identify the functional and manufacturing datums. Identify the functional and manufacturing datums. Identify the functional and manufacturing datums. Identify the functional and manufacturing datums and give the modified manufacturing drawing. And give the modified manufacturing drawing. So the drawing is as shown in the figure. So the component drawing is as shown in the figure. So the dimensions are mentioned. So they have asked us to find out the functional and manufacturing datums and suggest manufacturing dimensions and give the modified drawings. So here, what will be the functional datum and manufacturing datum? Now, for this, so I told always whenever there is a hole in the component, you consider that as the manufacturing datum. So I'll just redraw this without any dimensions for representation of functional datum and manufacturing datum. So the functional datum is, before starting with the procedure, we need to show the functional datum. That is XX, and the machining sequence also we need to write. Machining sequence. So here the machining sequence is turning of dia 60, turning of dia 60, and then turning of dia 25, so this is the diameter, okay, because it is a circular component. So turning of this dia 60, turning of dia 25, and then drilling hole of dia 8, that is this one, and then grind, because we are drilling in the circular components, hence we need to grind that surface. So these are the machining sequence, and this is the functional datum, and this is what we are shown in the drawing. And then we'll now start with the procedural steps. The first one, decide the required manufacturing datum. First, decide the required manufacturing datum. So in that condition, now here, so I always prefer when the component is open, if you are holding from this side, you always prefer the open face as the manufacturing datum. That is this. So datum A is represented as, that is the open end surface, as manufacturing datum, which is shown in the figure. That is the first step. Second, decide required manufacturing dimensions. Decide required manufacturing dimensions. Decide required manufacturing dimensions, and in the bracket, which also includes deciding vomited dimensions. also includes deciding omitted dimensions. I just write over here omitted dimensions as this. Now I take this figure itself and I'll eliminate the datum and all. Now, what is the functional datum we have chosen? This, isn't it? And the dimensions correspond to this functional datum are very important. This and this. Hence, the manufacturing dimensions are 25.1 to 25. I'll just name it as A, and 19.94 to 20.06. I'll just name it as B. A and B. So the tolerance among this A is how much? 0.12, and tolerance among this is again 0.1. So now big question is which dimension we need to omit, because both the dimensions has got the equal tolerance. The question was that the tolerance of the dimensions which is the dimension which is having the maximum tolerance, that dimension we need to omit. But here both the dimensions have got the equal tolerance. In that conditions we need to omit the dimensions which is inside. So among these two dimensions, which is inside? This is inside. So we are going to omit these dimensions, and I am going to show it over here. So this dimension was, and this dimension was mentioned, or what we had taken as important, that is 25.12 and 25. This we represented as A, this we represented as A, and this dimension is 20.06 and 19.94. This we represented as B, and this we have omitted because it is inside. Is that clear? So once you omit these dimensions, how are you going to define this? There must be one more dimension, right? Hence, we are assuming one more dimension as Z. But we need the overall dimension also, that is L, which is 80. Which is 80. Next, determine the tolerance for each of the new manufacturing dimensions. So I'm just not going to write this step because of time constraint. You can write that. Third, determine the tolerance for each of the new manufacturing dimensions. The omitted dimension tolerance was 0.12. We need to substitute equally this with respect to L, A, and Z. 0.04, 0.04, and 0.04. That will be okay? No, because this L covers the entire length. Hence, we are going to decide, give or allocate half of this tolerance to here, and remaining half we are going to allocate between A and Z. Is that clear? Remaining half we are going to allocate with respect to A and Z. Next, set the limits for all except one, that is the fourth point. We are going to set the limits. For L it is, we are going to, always it is given as 80. The lower limit will keep it as 80 and the upper limit will keep it as 80.06. And for A, we need to set the limits with respect to the tolerance of 0.03. We will keep the lower limit as 25 and the upper limit will change it to 25.03. Similarly, for Z, the basic dimension is not given, hence it is Z plus or minus 0.03. Next, the fifth step. Fifth step, with respect to omitted dimensions, I need to write. That is B. What will be the B equals over here? B is equal to, this B is equal to L minus A plus Z. B is equal to L minus A plus Z. Isn't it? If you look at over here, this B, that is omitted dimension, is equal to this overall length minus this length and this length. Then only you are going to get this length. Is that clear? So when this B will be maximum? When L is maximum and A minus A plus Z are minimum. A plus Z are minimum. That means A minimum and Z minimum. So it will be B max. You just write the value. That is 20.06. L max is what you have written, 80.06. Minus A minimum is 25. And Z minimum is what we need to find. 20.06 is equal to 80.06 minus 25 minus Z min. Hence Z minimum is equal to how much? It will come as 25 exactly. Come as exactly 25. So similarly, we will find it for the Z max. So for that, we need to consider this same equation, but for B minimum condition. B minimum. So when the dimension B will be minimum, when L will be minimum, and these two dimensions will be maximum. When L is minimum minus A is maximum and Z is maximum. So B minimum, how much? That is omitted dimension, since we need to take the same dimensions, it is 19.94. And L minimum is, here it is 80. And A max is 25.03. And Z max is what we need to find. Hence it is 19.94 is equal to 80 minus 25.03 minus Z max. So we need to find out the value of Z max over here. So Z max will come as 35.03. Z max is 35.03. Z minimum is, so it will come as 35. Sorry. So it will come as 35. Sorry. So Z minimum is 35. Z max is 35.03. Hence the tolerance between them is 0.03, what we have mentioned over here, or what we had decided in the previous step. So hence the new manufacturing layout, I am just going to represent it over itself. So this dimension is omitted, so I am just not going to represent this. Instead of that, I am going to represent the new dimensions, that is 35.03 to 35. This length also I changed as